A little known fact about the lunar South Pole is that several mountains and crater rims extend above the horizon and receive nearly constant sunlight for most of the year. These are known as the peaks of eternal light. They are not truly eternal since the best locations are lit only 90% of the time, but they are pretty close. Because the tilt of the moon is just 1.5 degrees relative to our orbit around the sun will only rarely dip below the horizon as viewed from a high vantage point on the South Pole. And if you were standing on an artificial tower even further up, you could theoretically have access to sunlight 24/7 year-round as if you were in orbit. The sun would skim the horizon all year long, never fully rising or setting. The lunar night lasts for 14 days, and the temperatures swing from 120 degrees Celsius at equatorial noon to minus 170 degrees Celsius at midnight. This makes it nearly impossible to host a settlement on most areas of the moon because you would need an unreasonable amount of battery storage and other extra equipment to survive through the long and cold nights. Sunlit polar peaks, by contrast, stay at a roughly constant, sub-freezing temperature around minus 50 degrees Celsius. The two main areas of interest are Shackleton Crater and Malapert Mountain. Shackleton is a large crater that is very close to the North Pole, and it is home to the best lighting conditions on the moon along its crest and in the surrounding area. A few of these points are lit about 90% of the time, but these are only about 100 meters across. Another challenge is that since this is a crater rim, there are very few flat areas to land large spacecraft and to build settlements and infrastructure. You can see in this terrain elevation map that even the best landing locations are considerably small and bumpy and would not be safe for a human landing of Starship. So future settlements may need to plan for significant transportation infrastructure, including building landing pads. There's also a large permanently shadowed region within the crater itself. These are all over the south pole of the moon and contain water ice and other volatiles that are uncommon on the moon. The final positive aspect of Shackleton is that points on opposite sides of the crater will have better lighting depending on the rotation of the moon and the season, so you could create seasonal settlements and move around to always have excellent lighting. This way, you could limit the total darkness to just a few periods of a few Earth days per year, which is much more manageable. The next site is Malapert Mountain. This structure extends 5 kilometers above the surrounding surface and also contains several peaks of nearly eternal light. The main advantage of this site is that it has constant line of sight with the Earth, since one of the mountainsides is on the tidally locked near side of the Earth, but since it is a giant mountain, it has even steeper terrain than the rim of Shackleton, and there are a few good landing sites anywhere close to the peaks. This site is also further from nearby permanently shadowed regions. There are a few more similar sites to these, but they all have very similar benefits and problems. Other than the lighting, the most promising aspect of these sites are the permanently shadowed regions within the craters. The rest of the moon has very hot lunar days that evaporate all the water into space, but water from comets and other sources can be trapped within these permanently shadowed regions, which stay below 100 Kelvin for millennia. This can create ideal conditions for building infrared telescopes, radio telescopes, and other scientific programs, and it also traps rare volatiles and water. There are several remote sensing missions that have identified signs of water, but the smoking gun evidence comes from NASA's L-Cross mission in 2009. This mission intentionally crashed the upper stage of its Centaur rocket into Cabeus Crater, and analysis of the plume estimated about 155 kilograms of water vapor and ice. They then calculated that the regolith at the impact site contained around 5.6% water ice by mass. The current estimate for all the water in these regions is at least 600 million tons, and likely more below the surface. This is expected to be mixed in with the lunar regolith, and the craters are very difficult to access, so the water will still be much more challenging to harvest than on Mars or in the asteroid belt. Aside from the Earth, there is generally a trade-off between solar power and resources, and there are many other nuances when deciding what to build where. As you see in this chart, the moon has low gravity, but it still takes 2,000 meters per second of delta V to land or to get into orbit, and there's no atmosphere to aerobrake with. This makes the frequently repeated idea of the moon as a refueling station for Mars not very practical. However, the lunar gas station idea could potentially make sense for moving lots of mass to the asteroid belt or beyond. And for the refueling idea, the idea is to use solar panels for electricity and then generate hydrogen fuel and oxygen oxidizer through electrolysis of water. The delta V needed to get to the moon is also low enough that you could potentially have round trips to low lunar orbit with orbital refueling and aerobraking with Earth's atmosphere. and we can get there in about a week, which makes it less risky for humans to visit. Everywhere else in space is so far away that it only makes sense to send people as permanent settlers, in my opinion. The biggest downside is the total amount of water and how difficult it is to access. The 600 million tons will be more than enough water for lunar outposts and maybe even towns, but the resources are severely limited compared to other exploration targets like Mars and the asteroid belt, and there is no atmosphere for plants or for generating oxygen with. The main advantage is that the solar radiance is over double that of Mars, and at the few peaks of eternal light sites, the average solar panel could be up to 5 times that of Mars and 15 times what you get in the asteroid belt. So overall, there will be a few sites that are great settlements, but no real industrial scale potential for building an interstellar ship or anything like that. And the sites and resources are in fact so limited that it is creating some controversy over which countries or companies will have access to them. The Outer Space Treaty says that no nation can claim territory in space, but if the peaks of eternal light are the size of football fields, roughly, then it will really be a race to claim them, and NASA has said that they want to establish safety zones around their sites where other countries can't land and potentially blast rocks everywhere. Every country has some planned missions to these sites, so we will see some pretty significant exploration in the next 20 years that should answer most of the remaining questions. So, in conclusion, should we settle these sites and the moon in general? I think yes, and making this video actually improved my perception of settling the moon relative to Mars and other locations. It can make for some good small settlements, but I think that Mars and the asteroid belt will still be more significant in the long term, in terms of serious settlement and production for things like interstellar travel and large-scale control of the solar system. But you guys let me know what you think in the comments down below. And with that being said, make sure to like and subscribe and check out my other videos on this channel, and have a great day.